Hello students, today we are going to see our next practical, which is stepper motor interfacing. That means we have to connect the stepper motor to 8051 microcontroller. Okay, so we know that what is stepper motor. So its name indicate that stepper means steps and motor. So this motor is rotated when we provide a particular step to motor. The motor is rotated when a particular steps is provided to motor. So therefore it is called as a stepper motor, because motor is rotate when a particular steps are provided to it. So in this practical we study how stepper motor work and how to program a stepper motor to connect it to the 8051 microcontroller. Okay, the aim of this experiment is to design and study stepper motor interfacing using 8051 microcontroller. That means in this experiment we study how stepper motor is connected to 8051 microcontroller. Okay, and the objective of these experiments are to understand the working of stepper motor, write the program for connecting or interfacing stepper motor to a 8051 microcontroller, and assemble and test the program whether it is correct or not. Okay, so these are the main objective of this experiment. Now before going to see interfacing the 8051, first of all we see how stepper motor is work. So this is the stators, these are the stators, and this is the one rotor. So these are four poles. So there are four poles, A, B, C and D. A and B are considered opposite to each other, and C and D are placed opposite to each other. So there are four stators: stator A, stator B, stator C and stator D, and there is only one rotor. Okay, so this rotor is rotate between these four stators. Okay, so now the stator A and stator B are connected to each other, and stator C and stator D are connected to each other. Okay, so this is the stator A, stator B, stator C and stator D is nothing but a magnetic coil, are nothing but our magnetic coil. Okay, so once again I repeat, there are four stators: stator A, stator B, stator C and stator D, and there is only one rotor which is placed in the middle between these three stator. Okay, now the stator A and stator B are connected to each other, and stator C and stator D are connected to each other. Okay, now so stator A has N pole at this side and south pole at this side. Similarly, B has south pole at this side. Stator D has the nth pole, and stator C has a south pole. Okay, and we know that opposite gate attracts to each other. Opposite gate attract to each other. Okay, so the first position of stator is look like this. The first position of stator is this. It is place in a straight line. It is a place in straight line with A and B. So when the current flow through A to C, A to B, the current flowing through A to B, they this rotor is rotate. This rotor is rotate because at this stator, at this A stator, this is a north pole, and at this stator there is also north pole, and at stator B this is south pole, and there are also a south pole. So the south pole of this rotor is attract towards the north pole of A and D. The south pole of stator is attracted to the north pole of A and D, and similarly north pole is attracted to the south pole of C and B. So this is the first rotation. This is the first rotation. Okay. Now look at in this diagram. This is A stator, this is B, this is C, and this is D. Now the current flowing through A to B. The current flowing through A to B. So when current flow through stator A and stator B, though this pole is become a south pole. This pole here, at the stator A, this is a north pole, and this is a south pole. But when current flowing through A to B, the north pole becomes south pole, and this south pole become north pole. Here, this is here in first diagram. here there is a north pole, and there is now in this diagram there is a south pole, and at stator B here the south pole, but in this diagram at stator B there is a north pole. Why the stator A become north to south and B becomes south to north? Because there is a flow of current between A and B. So whenever the current flow between A and B, the north pole becomes south pole, and south pole become north pole. Okay, so there is a south pole. So this rotor is a deflect. This rotor is a deflect because the south here this rotor has south pole. This is a south pole and this is a north pole of rotor. So when A become a south pole, then this south pole repel the rotor south pole. This south pole of stator A repel the south pole of a rotor. Okay, so there is a rotation. There is a rotation. So this south pole, the south pole. So the position of south pole is here. So when N become S, then this rotate in this direction. So the position of rotor in is a look like this. So first position is here at this point. This rotor is at here. The south pole of rotor is at here. But when north becomes south and south become north, then this south pole is rotate in this direction. So it is between north and north pole. So this south pole is a place between north and north pole, and this north pole is between south and south pole. Okay, then next, when the current is a flow from C and D stator, this is C and this is D stator. So when the current flowing from C and D stator, then again this north pole become south pole. This here at stator C, this is a south pole. So this south pole become north pole, and this north pole become south pole. So again this is the north. So south pole is placed between, because opposite attracts get each other. So this become north and this becomes south. So when this pole becomes, this north pole becomes south pole, then this south pole is again rotate in this direction. So the third rotation is at this position. So first position, so this south pole plays at between A and D. So then again it rotate and it plays between B and D. Then again it rotate and it plays between B and C. So then again fourth rotation it rotate and it is placed between C and A. So first rotation is between A and D, second rotation between D and B, third rotation between B and C, and the fourth rotation between C and A. So in this way rotor is rotated. So in this way stepper motor is rotated. When we provide a magnetic field or current to a particular stator, then rotor is rotated, because the north and south pole, opposite poles attract each other and same pole repel each other. Okay, so in this way rotor is rotated. Here both A and D has a north pole, so therefore the south pole of rotor is between A and D. So in second diagram, here the north pole becomes south pole, and this south pole become north pole. So therefore this stator is a rotate and come in between B and D. Look at the figure B, second figure. Then same condition when this C and D, the north pole of C is south but it changes to north, and the D has a north pole, it changes to south. So when this pole is changes, this rotor again rotate in this direction. So this rotation is in clockwise direction. This rotation is in clockwise direction, and this rotor rotate at 90 degrees. Look at, first it first it rotate in this direction, then it rotate this direction, then this rotate in this direction. So it continuously rotate. So this rotation make a 90-degree angle. Okay, so for first, so for here the first rotation, this rotor rotate in clockwise direction. So for clockwise direction, here this is the clockwise direction. So first rotation is 1001. The first rotation is 1001. Then next rotation is 1010 here. Here the rotor is rotate in clockwise direction. So for clockwise direction, we take the step 1001, then 0101, then 0110 and 1011. If the rotor is rotated in anti-clockwise direction, from anti-clockwise means what? This is start this the rotation starting from this point, then this point, then this point, and this point. So this is the anti-clockwise, but this rotate in a clockwise. So we take the first step as a 1001. So for this rotation, it take the step 1001. Then for second rotation, this rotation it take the step 0101. Then for the third rotation it take the step 0110. Okay. Then for the fourth rotation it take the step 1010 if clockwise, and if it is anti-clockwise, then steps are reverse. So first step is 1010, second step is 0110, next step is 0101, and the next is 1001, last step is 1001 if it is move in a anti-clockwise direction. Okay. So now this is the interfacing diagram of 8051 microcontroller with stepper motor. So this is the 8051 microcontroller. So here we use port 1 of 8051 microcontroller. So this is the stepper motor. This is the stepper motor, and these are the four stator A, B, C, D. These are the four stator of stepper motor. Okay. Now, so this is the here the 5 voltage supply is provided to 8051 stator to activate the stator or to activate the motor. Okay, then these four stators are connected to port P1 of 8051 microcontroller. This stator is connected to port P1 of microcontroller. Here, this is A and B. A and B are connected to each other through this coil. This is stator A, this is stator B, this is stator C, and this is stator A. Sorry, this is stator D. Okay, so stator A and stator B are connected through this coil, and similarly stator C and stator D are connected through this coil. Okay, so whenever we provide a current, whenever we provide the current to these two pins, then A and B, the current flow through between A and B, and then rotor is rotate, and when we provide the current C and D, then it again rotate. Okay, so in this way the stepper motor is connected to 8051 microcontroller. So this is the buffer circuit. This circuit provide a buffer. Buffer circuit means what? Buffer means what? Its input is same as its output is same as its input. Its output is same as its input. Okay. So in between 8051 microcontroller or in between stepper motor, we provide a buffer circuit. So buffer circuit protect the stepper motor from any damage. Okay. Now here the interfacing program. Okay, now we know that there are four steps. There are four steps. So this is 1001 means 9, 0101 means 5, 0110 means 3, and 1010 means 8. So 9, 5, 3, 8. 9, 5, 3, 8. Okay, so now let's start with program. This is hash include reg51.h. Hash include reg51.h. This is the header file of 8051 microcontroller. Here we declare a delay function. Here we declare a delay function, void delay void, and here void the main function. So within the main function we declare a while loop. So here we take a while loop. Why we take while loop? Because this stepper motor is continuously rotated. This stepper motor is continuously rotated. Therefore, here we take the while loop. Okay. Now, here we provide a steps. Here we provide a steps to each stator. So, first step is 1001. 1001 means 9. Okay. So, therefore, 9 number 909 is provided to P1. Why P1? Because here we use the P1 port of 8051. Here we use a P1 port of 8051. Okay. Then it gives some delay. It gives some delay. So after this delay, again next step is provided. Next step is 0101. That means this is a 5. So next step is provided to 05. The this next step is provided to P1 and it gives some delay. So after delay, it again provide the third step, which is 6 here. The third step 0110. This is the sixth number. So third step is provided to P1 and then after delay again the last step is provided to P1. So in this way we provide a fourth step through a P1, through a port P1 to a stepper motor. And when stepper motor get these steps from 8051 microcontroller, then the motor is rotated continuously. Okay. So here the here we declare a delay function. Here we define the delay function. So here we take the two variables j and k, which are the integers. Okay. So j is equals to 0, j is less than equal to 255, j plus plus. Now here we take the 255, j starts from 0 and end with 255. Why 255? Because 8051 is a 8-bit microcontroller. 8-bit microcontroller means what? It perform the operation on 8-bit data only. Microcontroller perform the operation on 8 bits data only. So it is basically a 8-bit microcontroller. Therefore here we take the 255. 2 raised to 8. There is a 8-bit data. A microcontroller is a 8-bit microcontroller. So 2 raised to 8. So 2 raised to 8 is equal to 256. So therefore here we take j is equals to 0 to j less than equal to 255 and j is continuously increasing. Similarly, k is equals to 0, k less than equal to 255, k plus plus. Okay. So therefore here we define a delay. Once again I repeat. So stepper motor. Stepper motor is a motor that rotates continuously when particular steps provided to it. So when current flow between coil, then this rotor is continuously rotated in either clockwise direction or in a anti-clockwise direction. So in this diagram this rotor is rotated in clockwise direction. So for the clockwise direction there are four steps: 1001, which is 9, 0101, which is 5, 0116, which is 6, 1010, which is 10. Okay. And if we go from anti-clockwise, if the rotor is rotate from anti-clockwise direction, then then the steps is the first step is 1010, next is 0110, next is 0101, then 1001. This is the last step if we consider an anti-clockwise direction. Okay. Then by using this table we can write the program. So here we define the header file, here we declare delay function, here we declare main function, then we take the while loop because motor is continuously rotated, then we provide the each step to a port P1. After some delay we provide four steps to port P1. Okay. Then here we declare a delay. So in this way stepper motor is a interface to a 8051 microcontroller and it will be continuously rotated. Okay. So this is the interfacing of stepper motor with 8051 microcontroller. Okay. Now we will stop here. In next lecture we will see our next practical.